Imagine for a moment a tiny metallic explorer, smaller than a family car, hurtling through the cosmic darkness. It has traveled for nearly half a century, far beyond the familiar lights of our planetary neighborhood. This is the story of Voyager 2, a testament to human curiosity and ingenuity. Launched in 1977, it carries with it the hopes and dreams of a species that dared to look up at the stars and wonder what lies beyond. You know, it's more than just a machine of circuits and wires. It's like a bottle cast into the cosmic ocean, carrying a message from Earth to any civilization that might one day find it. Its journey is really our journey, a silent, lonely voyage into the unknown. The scale of this adventure is almost impossible to comprehend. Voyager 2 is now so far away that a command sent from Earth, traveling at the speed of light, takes more than 18 hours to reach it. Think about that. You could actually watch a whole season of your favorite television show in the time it takes for our signal to cross the vast emptiness of space. And then, well, you'd have to wait another 18 hours for a reply. This immense distance makes every communication a delicate and precious event, a faint whisper across billions upon billions of kilometers, connecting us to our most distant robotic pioneer. In the late 1970s, a rare planetary alignment, occurring just once every 176 years, made Voyager's grand tour possible. NASA launched two identical spacecraft, Voyager 1 and Voyager 2, to seize this fleeting opportunity. Voyager 2's path let it visit all four giant planets, while Voyager 1 took a faster route for a close look at Saturn's moon Titan. This twin approach gave us a sweeping survey of the outer solar system, a masterful cosmic billiard shot. On July 21, 2023, a routine command from NASA's Jet Propulsion Laboratory accidentally tilted Voyager 2's antenna just 2 degrees away from Earth, enough to sever its vital link. The stream of data and updates stopped instantly. For the Voyager team, it was like a friend suddenly going silent. All they could do was wait, staring at a silent screen, hoping for a sign. With the knowledge that Voyager 2 was still operational, the mission team prepared their audacious plan. They would use the Canberra Deep Space Network antenna to send a command, but this would be no ordinary transmission. They needed to, essentially, shout across the solar system, sending a signal so powerful that it might be detected by the misaligned antenna's periphery. The command itself had to be incredibly simple: turn back towards Earth. It was a digital nudge, an interstellar shout designed to wake the slumbering probe and convince it to phone home. The chances of success were slim, but it was a chance they had to take. The team calculated the precise frequencies and timing needed to send this high-power command. On the 4th of August, they pointed the giant dish in Canberra towards Voyager 2's predicted location and blasted the command into the cosmos. Then, the long wait began. It would take over 18 hours for the signal to travel to the spacecraft, and another 18 hours for any potential response to travel back. For 37 agonizing hours, the team at JPL could do nothing but wait and hope that their shout had not been lost in the cosmic wilderness. It was a test of patience and a measure of the immense scale of the void separating us from our creation. Long before it ventured into the dark, Voyager 2 began its grand tour at the court of the King of Planets, Jupiter. In 1979, it swept past the colossal gas giant, and our view of the solar system changed forever. The images it sent back were honestly breathtaking, showing a world of swirling, psychedelic clouds, violent storms, and colors more vivid than anything we had imagined. The Great Red Spot, a storm large enough to swallow the Earth whole, was revealed not as a static feature but as a dynamic, churning vortex. Voyager 2 showed us that Jupiter was not a placid giant but a world of unimaginable power and atmospheric chaos. One of the mission's most stunning discoveries at Jupiter was, well, completely unexpected. As the spacecraft flew past the planet, it turned its cameras towards the dark space around Jupiter's equator and captured the first-ever images of a faint, dusty ring system. Until that moment, Saturn was thought to be the only ringed planet in our solar system. This discovery proved that rings were not a unique feature but could be a common characteristic of giant planets. It was a fundamental shift in our understanding of planetary systems, all thanks to a single, well-timed photograph from a robotic explorer. 2 years after its encounter with Jupiter, in August 1981, Voyager 2 arrived at the jewel of the solar system, Saturn. Famous for its magnificent rings, Saturn had captivated astronomers for centuries. But our view from Earth was, well, pretty limited. Voyager 2 provided an unprecedented close-up, revealing the rings to be an astonishingly complex system of thousands of individual ringlets, kind of like the grooves on a vinyl record. It discovered these strange radial spokes that formed and dissipated within hours, and even saw tiny shepherd moons that gravitationally herded the ring particles, keeping the delicate structures in place. The rings were not a solid, static structure, but a dynamic, evolving system of ice and rock. The spacecraft's instruments also peered beneath Saturn's hazy golden atmosphere. It found a world of incredible speed, with winds near the equator reaching up to 1,800 kilometers per hour. Like Jupiter, Saturn was a place of immense storms. Voyager 2 detected lightning strikes thousands of times more powerful than any on Earth. The data suggested an incredible weather cycle. This lightning superheats methane gas in the atmosphere, turning it into soot. As this carbon soot falls towards the planet's core, the immense pressure squeezes it into solid diamonds, which eventually melt into a rain of liquid diamond deep within the planet. In January 1986, Voyager 2 made history. It became the first and to this day the only spacecraft to ever visit the ice giant Uranus. From Earth, Uranus is little more than a faint bluish-green dot. Voyager 2 transformed it into a world. What it found was a planet of subtle beauty and profound strangeness. Unlike the turbulent atmospheres of Jupiter and Saturn, Uranus appeared as a nearly featureless, pale aquamarine sphere. This serene exterior, however, hid a bizarre secret. Uranus is tilted on its side, with its axis pointing almost directly at the Sun. It essentially rolls through its orbit, resulting in extreme seasons where each pole gets 42 years of continuous sunlight followed by 42 years of darkness. This extreme axial tilt is thought to be the result of a cataclysmic collision with an Earth-sized object early in the solar system's history. This impact may have not only knocked the planet over but also caused it to lose much of its internal heat, which could explain why its atmosphere is so much calmer than those of the other gas giants. Voyager 2 also made a crucial discovery about Uranus's magnetic field. It found that the field was not only strong but also dramatically tilted relative to the planet's rotation axis and offset from the planet's center. It's a messy, lopsided magnetic field, unlike any other in our solar system. In August 1989, 12 years after it left Earth, Voyager 2 reached its final planetary destination, the deep blue, windswept world of Neptune. This was the grand finale of its planetary tour, and honestly, it did not disappoint. The spacecraft revealed a vibrant, dynamic planet, far more visually active than Uranus. Its most prominent feature was a massive rotating storm system dubbed the Great Dark Spot, similar in nature to Jupiter's Great Red Spot. This colossal anticyclone was about the size of Earth, with the fastest winds ever recorded in the solar system, gusting at over 2,100 kilometers per hour. It was a world of extreme weather. Voyager 2's encounter with Neptune also solved a long-standing mystery about its rings. Observations from Earth had suggested that Neptune had incomplete rings, or arcs. Voyager's images showed that these were actually bright clumps within a complete but very faint and tenuous ring system. The spacecraft discovered 4 new rings and 6 new moons orbiting the ice giant. The largest of these newly discovered moons was Proteus, a dark, irregularly shaped body so heavily cratered that it appears to be on the verge of shattering. Each discovery added a new layer of complexity to this distant world. After leaving Neptune behind, Voyager 2 began the next phase of its epic journey, the voyage to the stars. Its mission was to cross the boundary where the sun's influence ends and the vast expanse of interstellar space begins. This boundary is called the heliopause, the edge of the protective bubble of solar wind and magnetic fields that our sun creates around the solar system. In November 2018, after a 41-year journey, Voyager 2 finally crossed this frontier, joining its twin, Voyager 1, as the only human-made objects to ever enter the space between the stars. It is now truly an interstellar traveler. This journey into the interstellar medium is profoundly important for science. Voyager 2 is our only direct source of information about this unexplored region. Its instruments are measuring the density, temperature, and composition of the interstellar plasma, cosmic rays, and magnetic fields that exist outside our solar bubble. This data helps us understand the environment our solar system moves through, and provides crucial context for understanding the conditions around other stars. Voyager 2 is a pioneer, sending back dispatches from a place we have only ever been able to dream of visiting.